Hello and welcome to Getting Beyond the Basics with NumPy Part 2. In our Part 1 series, we looked at creating arrays and playing with some arrays and doing some slicing and pulling information from arrays. And I really showed you the power of NumPy by comparing it to just the regular Python package and array operations you could do within Python compared to what you the processing power of NumPy. So in this video, I want to talk to you a little bit about array shapes, what are array shapes, and how to maybe even reshape your arrays, multi-dimensional arrays, and I want to talk to you about how to append and join a series of arrays together. Say you have two separate data sets and you want to combine them. It's very easy to do within NumPy. And how to perform mathematical operations across your arrays and maybe just a section of your array or your entire array, all of which is very easy to do within NumPy. So without too much more explanation, let's jump over to our Jupyter Notebook. And if this looks funny to you, if this doesn't look familiar to you, I have a video series on demystifying data science is what it's titled. And it's a step-by-step process. I'll walk you through on how to download this open source free software. And if you're coding in Python, I highly recommend you do it in Jupyter Notebooks. So I'm not going to get into much more of that here. We're just going to jump into coding with NumPy. So let's import the package. Import NumPy as NP, and NP, as I stated previously, that's the conventional naming for NumPy. So when you want to run NumPy functions, you have to always name NumPy. If you import it, I can import this as that. I would just have to call that every time I want to run NumPy. But for readability's sake and for other people to understand your code, it's just conventional to call it NP. So let's run that. It's now live within our notebook, and we can start performing NumPy functions. So let's get our first data set together. We're going to call that first data set A, and that A is equal to NumPy. We're just going to create a random set of 10 items. Not a random. We're going to create an array of 10 items, and we're going to just call that arrange 10. So that's just going to print out a series of 10 numbers. Let's print A, show you what that looks like, and it's Shift-Enter to run each cell. Hit Shift-Enter, and that's going to run each cell of code for you. So we have our first array. We have arrange 10. That is going to just spit out. It's just going to essentially tell NumPy to start counting and cut off at your 10th index number. Now we have our first array. Single-dimensional array, pretty easy to work with. I mentioned shapes. We need to understand kind of what a shape of an array is, and to get that, we just type in our array and then just type shape. And what it is single dimension, 10 items. So it's just a very basic shape. It's just telling we have one array of 10 items. Now, there will be times when you come across instances where you're going to want to reshape your array. So I want this to be displayed vertically. I want to manipulate this in a way that this array is vertical. Very easy to do. Similar to the transpose method in Excel, if you're familiar with that. This in Python, it's called reshape. So let's name this reshaped item AA, and that's going to be equal to our original list, which is A, and we're just going to call reshape. If I can spell. And when you reshape items, it goes in two parentheses, and that's going to be, we want 10 rows and 1 column. Pretty straightforward there. When you're dealing with multi-dimensional arrays, it's always rows and then columns. So that's something that you'll have to just get used to and get familiar with, rows and columns. And then let's print that out so we can just visualize what we did there. And look, it took our A array and reshaped it into a vertical array. Pretty cool. Pretty cool stuff. Um, and just a sanity check, a validation check, we can ask Python, hey, what is the shape? What's the shape of AA? And validation check, sanity check there. It's just spitting out what we initially imputed, what we initially told it to shape it as, which is pretty cool. Just to really see what's going on behind the scenes there. Okay, so let's perform a mathematical operation on this new array we created. So let's do AA2 is what we're going to call that, because we're going to multiply AA, that array we just created. Pardon the naming convention. I'm terrible at naming things. AA2 is going to be equal to the array, that vertical array, times 2. And let's print AA2. Shift Enter runs that, and we get our vertical array. We get our vertical array we originally got here. Started with this, then we made it a vertical array, and now we took that vertical array and multiplied each and every single item by 2. It's an iterative process. Excuse me, sorry about that. And it goes line by line. It goes item by item and multiplies each item by what we specified up here. And so, pretty cool, pretty easy. You can already start to see that power of NumPy, the power of Python unfold right before our eyes here. Way faster, easier than say Excel, or much easier to work with here. Okay, so we have this array we've performed a mathematical operation at. What if we just wanted to do we just wanted to take a few items and say perform an operation on just a few items out of our entire array. In NumPy part 1, in our first video, we talked a lot about slicing. We can pull items and then perform operations on just those isolated items. So let's do a refresh on slicing here, just by pulling some items, and we're going to name this new array that we're going to take a subsection of array AA2. So we're going to call it sub AA2, and that's going to be equal to AA2. And then say we just want to look at say the first through the third indexed item. So if you remember slicing it, everything starts at index 0, and then when you name the last index item, that's the cutoff point. And so what we want to do is index 1, index 2, and index 3. These 3 items here, we want to multiply just those 3 items in our array by 2. And let's print that. Print sub AA2. And what do we get here? We get those 3 items multiplied by 2. Cool. So I hope you see kind of the power here, and just kind of how when we start to combine some of these operations together, and how they work dynamically with each other, and how easy it is to just kind of build upon these foundational concepts. Okay, so now let's move on to two-dimensional arrays, and two-dimensional arrays are kind of more real life stuff. When I say two-dimensional arrays, multiple rows, multiple columns, rather than just this one series, this one set of an array. 2D data is more real life stuff. So let's create a random two-dimensional array. Let's name it X, and let's do random integers. So from the random package, random.rand int, we want series from 0 and random numbers from 0 to 100. And then the size, we want to name the size of our array, meaning how many rows by how many columns. We want 3 rows, say 10 columns. And then let's print X. So we're going to have a two-dimensional array, 3 rows, 10 columns. Look at that. We specified the size, numbers, items between 0 and 100, so random numbers between 0 and 100, which we have here, and we have 30 items. Pretty cool. Pretty easy to create random sets of data. Okay, so in our first video, we talked about slicing and pooling or accessing elements of an array. With multi-dimensional arrays, it's very similar process. We just have to name the row and column where we want to pull those individual items from. I'm going to show you how to do that. So all you have to do is name the array you want to pull from, and then you want to name the row and name the column. So this is going to return the first item. So just like single series arrays, multi-dimensional arrays, everything is indexed on 0. So row item 0, or this is row item 0, column item 0. It's going to be this first item. So this line of code is going to return a 61. We have 61 there. It's similar to the match function in Excel. You just have to count. What item do you want? You want this item. You need row, the first index. You want to do 1, 2, 3, 4, and you get that number there. So pretty easy, pretty intuitive and straightforward. Performing mathematical operations on multi-dimensional arrays is the same as performing mathematical operations on single-dimensional arrays. Just to show you there, let's call this x2 because we're gonna multiply x by 2, and pretty easy to do so. X times 2, whoops, 2 equals sign there for some reason, and let's just print out x2 and show you. We have these 30 items, and we've multiplied each and every single item by 2, and it just goes through and multiplies all these items by 2. Pretty straightforward, pretty easy. Okay, so now we have our multi-dimensional array, and we have our single-dimensional array. That's, remember, A from up top. And what if those were our final 2 data sets that we needed to bring together? Pretty simple to do so. So if you remember A from up top, let's just bring it down here, print A, and we have our x2 data set. These say our task is to bring these 2 items together. Let's do that just by using the VStack method. So let's name our new array. This is going to be our final data set, and it's going to be called Y. And just to merge those 2 data sets together, we can use numpy.vstack. And we just need to name what item we want to stack on top of each other. We want to take A, and we want to take Y, and let's print that out. Print Y. Let's see what we get. Oh no. Why did that? Let's see. Oh, sorry. I called our Y. It's called x2. It says Y is not defined because it is not defined. Now it is. Now Y is defined. We took our A series and we took our x2, and now it's all contained within one array, and that one array is called Y. Lastly, now is once you have your data set, now we can start performing some operations on it. So this is really where the power and kind of the data mining, data processing happens. So what's the minimum nim? If this was thousands of numbers, still the same process. np.min, name your data set, and it's gonna print out the smallest number in the data set. np.max, the largest number in the data set. You want to print out the mean. Why? You see how easy this data is to work with. The median, np.median. Let's do that. Just the last one here. just to show you you can perform easy calculations on these arrays. So I hope you learned something. Let me know if you want to see anything else on NumPy. I'd be happy to create another video on this, but thank you for watching.